Okay, so today I'm going to continue doing a demonstration of a tracking algorithm. It's been quite some time since my last video, so today what I'll do is I will be showing a slightly improved design of an old algorithm that I used way back. So most of my recent algorithms were based on image characteristics. It's basically looking for similar images as the video frames come along. But before that, I used to do an algorithm where I would track based on a fake IR video, and so out of the fake IR video I would then track the warm objects or the hot objects and lock onto them, and then that's how I used to do the tracking. Let me actually show you an example of that. So here I have this code, video called car UAV, so let's run that. And so it looks like this. So as you can see, this is actually colored video source, and I just changed it to grayscale, and so you can imagine that this is an IR camera and these white things are the warmer objects. So the idea is to use a tracker or an algorithm that locks onto warm objects and follows them. So I'll do that here, but let me restart the video. Let's quit this and just rerun it, and let me focus on that so it's shown, and then now let me lock on to this guy. Okay, so there's being tracked, and because it's a white car, so it looks as on grayscale like a hot object. So this is what I mean by a fake IR video, but this is just a test algorithm, so it locks on, follows that, and it works. But that was an old design, so I thought of improving it to track other things. So let's stop this one, and I'm going to show you what I want to actually track for this test. So we are going to track this one here. So let me expand that. Okay, there you go. So what it is this is just a simple drone video. The drone is quite acrobatic, moves around, loops, barrel roll, all that sort of stuff. And this shouldn't be too hard to track, I think, because it's against the blue sky, clean bright blue background. There are a few patches of white gloss, but that should not be a big deal. I think it could, but and my original algorithm sometimes would struggle on that, but my new one has manages to at least not all the time, but manages to stick to the target. So that's the target drone. And let me pause here, because I think if we convert this to grayscale, let me forward if I can see an example of. So if we, so as you can see, if I convert this to grayscale, those 4 white dots, the white lights, could represent the location of the motors, which would tend to be hotter than the airframe or the background sky. So I think this is a good example. But it's also possible that, okay, I lost that. Let me forward. Okay, here we go. It's also possible that the middle of the drone might actually be hot. I do not know how it is in real life, but I just imagine that this is how it is. So since the middle has bright lights, if I convert this to grayscale, the body of that drone would show up as a warm part or a warm target. So I think this video is kind of a good fake IR example. And so since this switches from that to, let's say, the middle is dark, so then the algorithm has to rely on just tracking the the outside parts. So that's that. Let me just play that just to give you a sense of what we're after. And yeah, that seems to, okay, there you go. And it definitely moves around, flips around, so the profile keeps on changing, the shape keeps on changing because it zooms in and out. It flies away from the viewer and back to the viewer, closer to the viewer again. So pretty good example test. Not hard, but yeah, it's just a basic thing that we can test. So I'll quit that. And now let's use the actual algorithm. So let's not do our usual stuff of doing this. And here we go. So I still have the old one, so let me quit that. So let's actually switch this to the 3. Yep, and there we go. Okay, so that's the same videos earlier, just in grayscale. So I labeled here the first box as source video, so we know that that's what is being used by the tracker, and this is the tracker profile. And of course I can do that, and it's reflected here. So there you go. But I am not going to use this example because let me also change from white hot to black hot. There you go, we lost it there. Just so if I change that, then the center becomes either dark or white, which is consistent with what we're after. So I quit that. Actually, I forgot to show you something, so let me backtrack a little bit. The reason I was interested in using IR is I was happy with my other algorithms, but then I realized that it's probably much cheaper to use an IR camera on drone and it's much faster to process that information because it's just warm versus not warm. So if we look at some of these tests, so let me zoom that in. Okay, so this is probably from I think this is from an actual military drone to target a flying drone. So I'll pause here and orient ourselves around this image. So maybe I should backtrack a little bit. Okay, stop here. So on this image, the center black triangle-ish thing there is a flying wing drone, and that's supposed to be the target. You cannot see my mouse because I don't record it, but below that, to the right, is that little black dot. That's the drone. So it's supposed to chase after that flying wing drone and take it down. And so on the lower left is the point of view of the drone. So this is presumably the IR camera of that drone, and so the flying wing is just a little white dot. It's not a dot here because of course it's a triangular shape, but if I rewind it some more, when it's still very far away, it looks like just a clump of white pixels. And so here is where machine learning or deep learning would fail, because that definitely does not represent anything. It's not the shape of a particular object, it's just a dot. So the deep learning algorithm would just have to be trained on looking for white dots, but that's overkill. So it's much easier to just write an algorithm to find that. It looks like it's the hottest part of that image, so just zoom into that one and maybe that is your target. And so if I continue forwarding the frames, we then have it becomes bigger as it becomes closer, and so now we have this target and its shape is becoming much more discernible as a flying wing, and that's just fine. And so as you can see, So once I close in, if your IR is locking excuse me, if your IR is locking onto the hot engine, that's going to be that exhaust there. But if your IR, if that's not available, then your system should be able to distinguish between the black, dark gray sky against the gray shape. And so that's not a very high contrast target. So the algorithm should be able to find a way to figure it out. And so that's it. So let me rewind a little bit just so we see it again. And so the drone is targeting, and that's the problem. That's the problem statement in a way. And so in my mind it seems hard, but actually this is much easier than targeting, locking onto targets on the ground, because there's not much noise. You're just dealing with the sky, and if you have IR, there's not many other sources of infrared radiation or hot objects floating around the sky. So if you might end up with maybe 2, 3, 4, 5 drones in one area, but that's not a lot of noise. So that should be fairly easy to lock on. Whereas if you're looking down to the ground, there are just so many sources of heat and IR radiation: plants, rocks, cars, houses, windows. All those little things would have different levels of radiation, and that causes a lot of false signals. But here it's fairly easy. So let me quit that and show a second one, just to drive home the point that this should work. So this is, I think, from the same company. I paused it. So the target there is that, again, the white dot in the middle, near the middle. There's a little bit of a black line around it, but that's not part of the IR. That's actually part of the probably the testing to show what the AI or the algorithm was finding as the bounding box. So let's pause that there, rewind a little bit. Okay, so here this IR is actually much better than the earlier one, because this is much hotter, whiter against the gray background, whereas earlier there was just poor contrast between the flying wing and the background. And so if you have an IR algorithm, tracking algorithm, you should be able to have the flexibility to do this thing where it's high contrast, and then in cases where there's also poor contrast. And so as we imagined the edges, the tips of the bars here, so we can assume that this is a quadrotor, and so the tips would be the hot motor, so that's why it's a little bit brighter than the other parts. And then there's this weird lines at the bottom, so that's presumably the landing gear. It's also possible that the electronics in the center of the drone would be warmer, so we have that warm spot in the middle, which is fine because it helps us target. It represents a much bigger target, and so it helps the algorithm. And so that's why the sample video we have, where it was switching from black and white center of the drone, would be good, because this kind of represents different difficulties. Some drones might be hot in the middle, some drones might not be as warm in the middle, and so a good algorithm should be able to deal with that. But again, even with all that, we know that this is not going to be a big problem for a simple algorithm, because there's not a lot of noise. The problem here, I think, is it moves around quite a bit. So the algorithm is to be able to handle wide displacement of the target, combination of the target maneuvering and also the combination of vibration from the drone. So that's it. Let's now go to our actual demonstration. So earlier I had that, the 3, but I am going to show something different just to make it a little bit nicer. So here it's still the same thing. but I am using starlight, kind of in night vision goggles, so green representation. It's fake. It's this from the same video. I just used green as a way to represent the grayscale. So that's how it looks. And if I switch the toggle from hot to black, you can see that it changes. So let us now do the real deal. And I think, wait, I might have lost my, there we go. Oh, let's just redo that. There you go. And let's zoom in and let's target that guy. There you go. Now, as you can see, if I cancel that and I target, it actually moves faster. That's because my algorithm is much faster than the frame rate, which is what I want. Because if I want to add more complexity to the algorithm to solve for noise and mistracking problems, for example, I need more extra time, for example, to fix that, to do that. So if it slows down and it goes faster again. So that's let's redo from the beginning. Lock on. Now locking on, I don't have to click right in the middle. The algorithm figures it out. I can change to white hot, no problem. It should be able to carry on with the tracking. The problem here, so there, it's looking for, the reason it's jumpy when it's the normal color is because it's tracking the 4 different edges, and those 4 edges change quite a bit, move around a lot, so the target shifts all the time. Whereas if I change to this, it's more stable because the center is just almost there all the time. The reason I changed it to black is once it goes to the ground, I'll show you. Once it goes to the ground, the black trees on the horizon on the original video, when I changed it to fake grayscale or fake IR, it's actually much warmer than the drone. So the tracking system jumps to the trees, which is obviously incorrect and not ideal. But that's just limitation of my fake IR video. In reality, I suspect that the drone would still be warmer than the background heat from the trees, so that should not be a problem. The other thing to consider also is when you're, there you go, that's an example of the IR, the algorithm jumping to a different heat source. But the other thing though is, usually, let's say if you're targeting a reconnaissance drone, and which is, let's say, a kilometer away above us, so then you wouldn't have this risk of stray horizon or ground clutter dragging the tracking and the algorithm to it. So typically your problems would just be if you're daylight, the heat source from the sun, or reflections from clouds maybe. I'm not sure if that shows in actual IR video, but I'm just imagining that there might be something like that. So that's those are the main problems that we have to deal with. And also if there are, let's say, 5 different drones there, and if one drone is, let's say, hotter than your target and they cross paths, it's likely that the algorithm will jump to that other drone, but that's okay. Presumably all those drones are targets, so even if it jumps to another one, that's no big deal. You just have to deal with the new one and take out the second one. So that's what it does, and it will end the video. But let's run it one more time just for fun, because I like how this looks like it's a video from night vision targeting. And so here I'm just using the normal color, where the so there, when I'm doing that, it doesn't get distracted by the trees, because the trees here are dark, whereas if I switch that, the trees become black. and so you have to switch that so it doesn't get lost. So that's how it works. This is quite an improvement from my old one from I think 2 years ago, the one with the tracking the car. Number one, because this is much faster, and number two, this has additional logic to make it more robust to noise, and yeah, all those additional defenses that made the previous tracker poor. So here, this is now an additional element. So basically attaching an IR, hopefully a cheap IR camera on a guided drone, and then log on, point the thing to the right direction, right general direction, and let it do its work. And that's that. So I think this is sufficient for this part. I'll stop here. I did some changes to the UI just for the heck of it. Generally, it's just some stuff that I see on video for the real thing. So this is just making up things and trying to do something for fun. So I'll stop here and I will call it a day, and hopefully you guys liked it. And yeah, I'll do a couple more, probably a little bit more frequently than the last time. I have a couple of ideas lined up, so yep, hang it there, and thanks for watching.